Hello everyone, welcome to the discussion. We are at the last question of this particular series and let's get into the problem. This is a problem uh, based on vectors, right? And it totally carries 22 marks. So let's break down this and do it step by step, right? Um, Hello everyone, welcome to the video. So we are at the last part of this particular series, paper 2, question number 12. This question carries 22 marks and many sub-questions, simple, complex, extended questions are there. So let's break down this and solve it step by step, right? Hope you can see my screen. Right, we can just get started. First is very simple. Let's have the 3 points is given, A, B, C, and all are 3D points in a 3-dimensional space and K belongs to R. K is an unknown here. So the next part is write down A, B, and AC. So this is a basic vector, how to write. So Persian vector, we know, right? When we have a coordinate, Persian vector is very simple. But how to find A, B, and BC? So if your A is A1, A2, A3, like in vector form or in coordinate form, that will be good. So this is the way we will write. A is A1, A2, A3. And if your B is B1, B2, B3 in coordinates. If you want to find this particular vector, AB vector is B1 minus A1. So respective coordinates, you need to subtract B2 minus A2. And it's not, if you do A1 minus B1, it's wrong. B3 minus A3. So this is the thing we have to follow. This is general concept. Now just apply for AB. We are going to do AB, it's going to be K minus 1. So from B, then minus 1. Then minus 2, minus 2. Then 1 and minus 3. This is AB. Let's simplify. K minus 1, minus 4, minus 2. This is your AB. And let's do BC. Sorry, AC is has here. So AC vector is C minus A. That's simple. So 5 minus 1, which is 4. 5 minus 1, 0 minus 2, 2 minus 3. And this will go like this. 4 minus 2, minus 1. So this is my AB and AC. Very simple. And this will fetch us around 2 marks. That's simple it is. Next part. Given the points A, B, and C lie on a straight line, show that K is equal to 9. So K is our unknown, right? We need to prove that K is 9, and this particular condition is given. These points lie on a straight line. So what is the basic concept we have to understand here? If the 3 points on a 3-dimensional space lie on a straight line, then it should satisfy this. We should able to express AB is equal to, like it's nothing but collinearity. AB vector is equal to ABC. This is how the scenario, if they are, you can express this AB vector equal to lambda times BC vector. Wait a moment, AC vector, not BC. Right? So AB vector and AC vector should AB vector or AC vector should be a scalar multiple of this. And then it is a straight line. If not, it is not a straight line. Let's try what is AB, K minus 1. We know AB and AC, that's going to help us here. K minus 1, and here it is, minus 4, minus 2. You can just copy it. Equal lambda times 4 minus 2 minus 1. And let's equate it. When you solve, you will get a lambda and then you will get K. So this is the condition. That's simple. Now we can solve it. K minus 1 equal 4 lambda. Okay, two unknowns, I can't do anything. Let's go for the next. Minus 4 equal to minus 2 lambda. So they are equal vectors. So minus 4 and minus 2 lambda equal. So this will give us lambda is equal to 2. And when you substitute lambda is equal to 2 here, you will get k minus 1. K minus 1 equal to 4 times 2. K minus 1 is 8. K is 9. Yeah. So if the points are a straight line, this condition holds and we can derive that k is 9. Hence it is proved. That's simple. And next part. For k equal to 9, let L1 be the line passing through A, B, and C. Okay, so a line is passing through this. Find the vector equation of the line L1, and there is also one more sub question. Altogether, it's 10 mark. Let's do. So what is the vector equation of a line? Let's see here. This is the formula sheet. Here we go. So this is a vector equation of the line A plus B vector, and the parametric form, Cartesian form, all this have been given. So this is the vector equation of the line. Let's take it. Let's copy this AAHL 3.1. And let's get back to the solution page. Okay, so what is A vector here? R vector, we know it is a question vector. What is A and B and lambda? This is not the same lambda, right? We have already taken a lambda, so we should not get confused here. And let's solve this further. So we got a vector equation. A is a fixed point. We have to consider one fixed point here. Let A be fixed because I know every value of this. A is, what is given here? 1, 2, 3. So for a fixed point you are considering, and you have to consider one more non-parallel vector, right? Fixed point, you will take the, if this is your fixed point, you have to take the first A vector from your fixed point. Then the whichever multiplied with that lambda will be the non-parallel vector. So this is just a position vector. A is this. How to find A vector? Just OA vector. If you find OA is position vector, like just you write in this way, like origin to A. So everything will come as it is. This is your OA vector. That is A vector here. Then coming to the B vector, it should be the vector which, okay, we have started from, this is our line, we imagine A and B and C. So I've considered the position vector somehow from the origin. I have considered this OA vector. Then full AC vector we have to consider. So that should be your B vector in this case, right? So B vector is nothing but AC vector. We already have this AC vector and it is, let me show you. We found it in the first part itself. 4 minus 2 minus 1. Hope you can see here. 4 minus 2 minus 1. This is our AC vector and let's jump there. Now, the complete vector equation is vector equation of L1 is this. R vector is equal to, A vector is 1, 2, 3 plus lambda times B vector is 4 minus 2 minus 1. Right. So this is the vector equation and the problem stops over here. Right. So next part. L2 Cartesian form is given. Prove that L1 and L2 are skew. Okay, now we have to recall what are skew lines. So skew lines are the lines. They will be in different planes. They will not intersect. They will not be parallel. That's it. So we have to prove two things. They don't intersect and we have to prove they are not parallel, right? So first let's aim for not intersect. Parallel is quite easy. Let's convert. Okay, first line I have the vector equation, right? Let me convert this Cartesian form to a vector form. Okay, so our aim is here is find vector equation of L2. Okay, so vector equation formula, for a line, R vector is A vector plus lambda B vector. Already we use lambda for line 1, so let's change that constant here. And AB means, it's not same anyway. Maybe I can choose, this will be best. No need to repeat and confuse the values. Like S vector and D vector. Right, now we need to find what is S vector. So here from the Cartesian, if the points are given, we have tried. Here points are not given, but how to find we have to convert the Cartesian form in this manner. Let me show you. Actually, how the standard form of the Cartesian form, it is given in our formula booklet. And this is how it should look like. Can you see here? Cartesian form. So we have to make sure our equation in that form, and x naught, y naught, z naught, it will be act as a fixed point. What about the element? They are direction vectors. So let's convert this form, and then it will be easy to convert to vector form. And we are back to the solution page. Okay, so let me write L2 in this form. L2 is x minus 1 by 2, that is perfect. Y minus what? 0, you can put it with single y by 3. And I want z minus 1. So you take minus 1 and you put divided by minus 1. This will make sense. Same thing, but I represent it in a standard form. So x naught, y naught, z naught is a fixed point that we will consider for a line without the scalar multiplication, right? That part. And LMN are direction vectors. Right? And now we can convert the vector equation of it directly. You can put, so R vector is equal to fixed point is 1, 0, 1. So 1, 0, 1 plus mu times T is the direction vector, whatever associated with that constant. That is, it's 2, 3 and minus 1. This is actually 0. Right. So we got the vector form of L2. L1 also I have in vector form. L2 also we have. This is the vector L1 in vector form. Right. Now, actually, we are solving for skew. So let's take the points on L1 and L2. Right. If the points meet, if the points are like general points will make, and general points will be some equations with two variables. And this is how it will be. Let's aim for points on L1. For that, I need the vector equation form. So vector equation of L1 is R vector is equal to 1, 2, 3 and 4 minus 2, 1. Yeah. So points on L1, write the vectors in the vector equation, and points on L1 will be like this: 1 plus 4 lambda, 2 minus 2 lambda. So just make a equation out of it. And 3 minus lambda. Then points on L2. This will go like L2 equation is R vector equals 101 plus mu times 2, 3 minus 1. And let's make the points. The points is 1 plus 2 mu. This is all the general points we left, like 0 plus 3 mu, which is just 3 mu, and 1 minus mu. Now, let me equate them, the corresponding points, and let's try to fetch a solution here. 1 plus 4 lambda is equal to 1 plus 2 mu, and 2 minus 2 lambda is equal to 3 mu. 3 minus lambda is equal to 1 minus mu. So these are my simultaneous linear equations with two variables, but I have three equations. So you just check with, take any two, and we are going to solve it on the GDC, right? So I should get some value for lambda and mu, right? That's the first part. Then I pick two equations. It's our choice. Either you can, let me make it A, B, C equations. Okay, I'm going to pick A and C and solve this. So then after solving, I will get some lambda and mu values. I should substitute in the B equation. If it gets satisfied, they will intersect. If I substitute that in the unused equation, and if it does not get satisfied, okay, they are not intersecting. So right, so we have to prove not intersecting, because Qness is doesn't intersect, they are not parallel. Right, so let's get into the GDC part now. Okay, so how to solve this? Actually, what we need to solve, the equations. So simultaneous equation solver, we can go to the calculate menu, algebra, solve simultaneous system of linear equations, and it will ask for number of equations. We have three actually, but we are going to use only two of them here. And variables x and y, don't try to change lambda mu, let it be. So you treat x as lambda, y as mu. Okay, click OK. And first equation we should give in here, and second equation here. Let's go. Actually, the equation is, hope this is clear. Right. So 1 plus 4 lambda equal 1 plus 2 mu. That is one equation. And I pick the C equation, which I have marked. 3 minus lambda equal to 1 minus mu. But it's our choice. And let's give the input here. So 1 plus 4, it's not lambda. Here, lambda is x, right? 1 plus 4x is equal to 1 plus 2x. And let's get here. 3 minus x is equal to 1 minus y. See, I did a mistake here. Actually, the mu is treated as y, right? So y. So this is the equation, and we can click enter. We got minus 2 and minus 4. X and y is minus 2 and minus 4, but we will treat this as lambda first and mu second. Let's get back to the solution page. Here we go. So what I got, let me paste it here. Make sure this is lambda and this is mu. So lambda is minus 2, mu is minus 4, and okay, you need to substitute in B, right? So substitute star in unused equation. So I have not used the B part. Let's substitute. It's quite easy, so we can do it here. No need to waste time. 2 minus 2, lambda is minus 2. equal 3 times mu is minus 4, which is 2 plus 4, here minus 12. Of course, they are not equal. 6 is not equal to minus 12, which implies the lines doesn't intersect. Okay, so this implies L1 and L2 doesn't intersect. Okay, what is the second condition to prove for skewness? We have to prove they are not parallel, and it's very simple. Let me quickly give you the revision of this. So how we need to prove? We already have the Cartesian. We have to prove that L1 and L2 are skew. First one, vector equation of L2 we are framing. Actually, Cartesian equation is given. So vector equation formed. L1 already we have it. So write the general form of points of L1 and L2 and equate the corresponding points. Make the simultaneous linear equation. Two variables, but we have three equations. You choose any two and solve it simultaneously using GDC and find lambda and mu. Substitute in the unused equation. It does not get satisfied here, so we mean the line doesn't intersect. In case if it gets satisfied, they will intersect. Okay, now next aim is to prove L1 and L2 are not parallel. To prove L1 and L2 not parallel. Right, let's go ahead. Okay, non-parallel means like if it is parallel, one vector will be the scalar vector of the scalar product of the other vector, right? So here, let me take direction vector is what we need to take. Direction vector of L1, fixed point of noise, right? So direction vector of L1, which is, you can find it from the vector equation, which is associated with that constant. Like for L2, this is, which is associated with the mu. For L1, this 4 minus 2 minus 1. So 4 minus 2 minus 1 and direction vector of L2. Which is, I think it's 2 minus 3, 1. Yeah, 2 minus 3, 1. 2, 3 minus 1. Okay, if they are parallel condition is this. If they are parallel, you will able to write, like if this is S vector and this is Q vector, you will able to write S vector is equal to some scalar times Q vector. This is the condition. This is imaginary. We already have S and Q. Don't confuse. Let me try to apply this. So parallelism check. Okay, let me take L2 first. 2, 3 minus 1 is equal to K times 4 minus 2 minus 1. Let's solve this. 2 equal to 4K. So when you equate it, and you will get K equal to 2. Good. If K is 2, okay, wait a second. So here we need to do K is actually 1 by 2, right? But anyways, we'll get they are not parallel as. So K will be half. So K is half and we will get 2, 3 minus 1 equals half times 4 minus 2 minus 1. And solving it further, we will get this. 2, 3 minus 1 equals 2. When you take the 1 by 2, minus 1, minus 2. This pair is equal, but entirely is the vector equal? No. So we got an absurdity and it is not equal. So L1 and L2 are not parallel. They doesn't intersect, they are not parallel. Hence, L1 and L2 are skew. That's the proof. Got it? It's a very simpler one. And only we need to deal with the variables correctly here. Let's move to the next part, the last part. For k not equal to 9, pi be the plane containing A, B, and C. Find Cartesian equation of the plane pi. Okay. So what is the Cartesian equation? It's ax plus by plus cz. This is the Cartesian equation of a plane equals a constant d. Okay, we need a Cartesian and k not equal to 9 they have said, and the same ABC we have to take. First, let's try to find the vector equation. And then from the vector equation, it will be easy to find the Cartesian equation, right? So vector equation of a plane, let me share the formula sheet quickly. This is Cartesian equation. Yes, we need to find, but obviously we'll focus on this formula. But after finding vector equation of a plane, this is the vector equation. R vector equal to A plus lambda B plus mu C. Where A is a fixed point, B and C should be two non-parallel vectors here. That's the condition. So let's work in, we have to make this problem. The same formula, let's substitute it over there. Okay, this is vector equation of a plane. Okay, what is my fixed point? And then what is B vector? What is C vector? That is our idea. So this is your fixed point, AB vector, and AC is a different vector. So they are non-parallel vectors, right? So we have to take this AB vector and AC vector. So you treat B vector as AB, C vector as AC. And we already have that in our problem, so no need to solve it again. Let's go. R vector is equal to A vector, AB, and BC. A vector is just OA vector. Since it's a fixed point, but B vector is we treat it as AB, and C vector is AC vector. AB, AC we already have, and OA. K not equal to 9 they have said. So the very first, before solving K, we have an format, right, that we need to pick. So this one. This is my AB. This is my AC. And my A is 1, 2, 3. Right? So let's take that. And even you can quickly solve this before searching it. So what is A, B, and C? We can list it out. A is 1, 2, 3. And B point is given as K minus 2 minus 1. C is 502. Okay. My A vector is OA, which is just 1, 2, 3. My B vector is AB vector. Right? So K minus 1, minus 4, minus 2. And my C vector is going to be AC vector. So whichever in this particular equation, which is 4 minus 2 minus 1. Right? So let's make the vector equation of the plane. So vector equation of the plane is R vector is equal to 1, 2, 3 plus lambda times. We have already used lambda, so maybe so that is not a problem. It won't affect it. You can use our other constant also. We can use lambda times K minus 1 minus 4 2 plus mu times 4 minus 2 minus 1. This is the vector equation. Now, how to convert it like into the Cartesian form, like like XYZ form? It's very simple. R vector is a position vector. It can be written as xi plus yj plus zk, right? Or you can write like this. This is the easier way to interpret. Our vector can be written as x, y, z. These are the three components. And this is completely, if you convert it into a single thing, 1 plus lambda into k minus 1 plus 4 mu is what we got. And next, 2 plus, okay, lambda into minus 4, it's minus 4 lambda. So 2 minus 4 lambda minus 2 mu. And then 3 plus 2 lambda minus mu. This is all we got. And that's it. I got my x. X is 1 plus lambda into k minus 1 plus 4 mu. And y is 2 minus 4 lambda minus 2 mu. And my z is 3 plus 2 lambda minus mu. I got x, y, z. Let me mark it as, and I need to solve any two of the equation here. But our aim is to eliminate one of both the variables. This is the problem. I need x, y, z, lambda and mu have to be created. I won't take this because it is already having a k in it. That's the problem. So let me focus on this. Let me mark it as 1 and 2. Okay, my aim is to remove both the variables. That is lambda and mu. Right? So let me multiply the first equation. No, first equation we can take as it is. You get y is equal to 2 minus 4 lambda minus 2 mu. But second equation, I'm going to multiply with 2. So what happened? 2z is equal to 6 plus 4 lambda. Wait a second. So here there is 3. This is minus 2. So please note it. And 3 minus 2 lambda minus u. So that will be minus again. The second equation I multiply by a minus 2. Okay, let me multiply by plus 2 first. So I will get 6z, 2z, and then minus 4 is it? Minus 4 lambda, 6 minus 4 lambda minus 2 mu. Then I want to remove that mu and lambda, right? They have same, everything is same, only the sign is not. So I'm going to subtract, change the sign for every term in the denominator. So minus 2 lambda plus 2 cancel, this will get cancelled. And I got here y minus 2z equal to minus 4. Right? So this is the required plane equation. X is 0, like it is not in the x plane. So x axis. So this is the plane equation. That's it. So next part, the last part, it carries 9 marks. Here we go. Find a point on the plane pi, and we know the plane equation now, which is closest to the origin. So what is pi? It is y minus 2z equal minus 4. This is my pi. Okay, I should find a point which will be closer to the origin. 0, 0. This is what origin coordinate. Okay, let's go. Let's take the point. Let PQR be the point on phi. So how can we express it? If PQR is a point on a pi, I can substitute this point on a plane, right? X is not, so I won't substitute P. So then this implies P minus, P is, there is no X value, right? So Q minus 2R equal minus 4. Okay, my aim is now to find what is P and QR, right? And distance to the origin, next part. Distance to the origin should be minimum. They are telling closest to the origin. So next part is distance to the origin. this particular point. Distance to the origin. What is the point we have taken? PQR. And that will be written as P square plus Q square plus R square. It's a very simple three-dimensional distance formula. Let me show it to you. And here we go with the formula sheet. So distance between 2 points, when it is an origin, the other point will be 0. So just square those significant coordinates, right? And let's get back to this. This is the thing we have to take. Yeah. And here we go. So what is Q? Q can be written as 4, 2 or minus 4 or something, right? Where we can replace the Q. Q can be expressed in terms of R. So Q is equal to, here itself we can do 2 or minus 4, and I can substitute that here. So square root of P square plus 2 or minus 4 the whole square plus R square. Okay, the only problem is I have P. Because two variables I have. If it's one variable, easy to minimize. Now I am framing a distance function. Okay, D is equal to P is x coordinate, and our plane equation itself doesn't have, right? So we can imagine this P can be very, very closer to like origin, right? So x is the P coordinate. So if this is your origin, and this is 1, very close to 1. So we can minimize it to 0. P can be minimized to 0, but not other stuff. So P can be minimized to 0. So what happened to the function? The distance function will turn like this. D is equal to square root of 2 or minus 4 the whole square plus R square. This is the function. And next part, we form a function. Now we have to minimize this function, right? Because we need the closest distance. The distance have to be as minimum as possible. So D is equal to, I think let it be as it is. We can just use the graphing calculator, and this will act as a function, and we will minimize using analyzing the graph feature, right? And let's move to the graphical part. Okay, so let's type the function. It is square root of, based on R, let us treat it as a square root function here. Control and root. So that is a square inside. Two x minus, actually we have R, but here you can treat it as 2x minus 4 the whole square. Then we have inside the square root itself, it's a R square. That is, here we treat it as x square. That's it. This is my function, and let's graph it. We got it. Now I need to minimize this function, right? This is a distance function, and it should be very closest to the origin. So go to the menu, analyze graph, minimum. It will ask for lower bound and upper bound. Like you can just click lower bound, it's like minus 100. Upper bound is like plus 100. 1.6 and 1.79. We got the exact coordinate here, right? Let's get into the solution page. So this is what we got. So what we are solving for? To minimize this function, this is my r and this is my f of r, the distance. So the minimum distance is 1.79 and it is possible when r is equal to 1.6. Okay, r is 1.6, but I need to find the coordinate p, q, r. P we minimize to 0, so 0. Q can be written as 2r minus 4. So 2 times 1.6 minus 4 and r is just 1.6. We have to solve this. This is just a simple multiplication. Let me solve it here. So it will be negative 0.8. So 0, negative 0.8 and positive 1.6. This is the solution we have. And that's it. This is quite big problem, but very basic concepts over here. But where to apply, when to apply, how to convert the formula, that is the raw formula, into the structure we need in this particular question. That matters here. And hope this is helpful. So thank you so much for listening. Let's meet in the next series. Thank you, everyone.